For those of you with the book, we're going to be talking about, I'm going to be talking about vitamins, minerals, and water. The information is found in Module 1.5 and 1.4, I think. We're looking at the chemistry, functions, and categories of vitamins and minerals, and we'll look at some of the functions, and we'll touch on intake and excretion of water. We'll go over all of this again when we get to Module 5. Vitamins, some are considered essential, which, if you recall, essential means that they are required for the growth, repair, and maintenance of the body, and that if we don't get them, deficiency symptoms will develop that can be reversed when those nutrients are added back into the diet. Vitamins are organic compounds, which means they contain carbon, but also other elements. They are non-caloric. So and if you recall, calories means energy. So when you take that vitamin and you think it's giving you a lot of energy, it's probably the caffeine in your coffee. All vitamins are needed in tiny amounts, microgram or milligram amounts. And that's really tiny when you compare it to the amount of grams that we need for carbohydrates, proteins, and fats. That doesn't mean they're any less important. It just means that we need less of them in order for our body to function. Let me talk to you about bioavailability. Bioavailability refers to the amount absorbed and used by the body, right? Just because something has twice the amount of magic in it, just because something has twice the amount of vitamin C in it doesn't mean our body can use all that vitamin C. I think this goes back to a question somebody had about superfoods. There are no superfoods. There are different factors that can affect the bioavailability of food. Your health, the efficiency of your digestive tract, right? That's going to affect your ability to absorb and utilize nutrients, your nutritional status, how the food is prepared. Some foods, the nutrients in those foods are more bioavailable. They're more bioavailable if they've been heated. Others, if they are raw. I don't want you to worry about eat the food because you like it. I don't want you to worry about the preparation of it for nutrition reasons. If you are looking at this video right now, there's a good chance that you are getting adequate nutrients in your diet. This is information to help you in the future. Where are the nutrients coming from? When we talk about iron that comes from animal sources, heme iron is more bioavailable than iron from non-animal sources or non-heme iron. But there are things we can do to increase the bioavailability of that nutrient. Other foods consumed at the same time. If you consume, this is cocktail chatter for now, but if you consume foods that are high in calcium with foods that are high in iron, it may inhibit the absorption of both of them. So bioavailability refers to the amount absorbed and used by the body, and there are a number of factors that can influence the bioavailability of nutrients. The function of vitamins include metabolism. They're involved in helping us get the energy from the carbohydrates, proteins, and fats that we use. They act as cofactors for specific enzymes. Enzymes are proteins that act as catalysts that speed up reactions. I want you to remember that every single reaction in our body involves enzymes, energy, and water. And vitamins and minerals work with those enzymes to help them do their work. And there we go, right there. Protein-based molecules that catalyze chemical reactions. The different categories of vitamins include fat-soluble and water-soluble. You don't need to remember structures. You never need to remember structures. However, I will ask you to remember the difference between fat-soluble and water-soluble. And spoiler alert, fat-soluble are A, D, E, and K. Water-soluble are B vitamins, vitamin C. So whichever one helps you to remember will be what you use. This is a periodic table of elements. If you go into the gray matter in the back of your mind, somewhere you might remember having seen this in a chemistry class. These are our minerals. And because, it's there, I actually have a periodic table of desserts. Don't look at it too closely. It's not that accurate. Some of the functions of minerals include structure, like calcium in your bones and in your teeth. Minerals are also work with proteins, Like iron is involved with hemoglobin to help transport oxygen in the body. Iodine is part of the protein molecule thyroxine that's involved in thyroid function. And minerals also act as cofactors for enzymes during metabolism. Then we have water and the electrolytes. Sodium, potassium, and chloride are minerals, but when they are in a positive or negative state, they are considered electrolytes. They carry an electrical charge. Every reaction in our body moves on electricity: nerve impulse transmission, muscle contraction, heartbeat. Sodium, potassium, chloride, and water are involved in these reactions. The pH scale, you may remember, is a measure of the acidity or alkalinity or base qualities of a food, or, well, anything, I guess. Our pH is really tightly balanced between 7.35 and 7.45. And I'm going to show you a video in a second to make you stop worrying about whether or not that meat you ate or that orange that you didn't eat is going to cause you to get cancer. And here's a fun pH scale, because I could find it. All this information is true. The acid of our stomach is really low. It's just above car battery acid. And pure water is neutral, around 7. Rainwater is a little acidic these days.
Eating an alkaline diet help prevent cancer and other diseases? I'm Tamara Robertson, and you're hooked up to the feeding tube. Welcome to the show that serves up the real facts behind pop culture food myths. One of these is the alternative health belief that cancer and other diseases are caused by your body being too acidic, and that you can prevent them by eating a more alkaline diet. The pH scale measures the acidity of aqueous solutions like your body. It goes from 0 to 14. Pure water is neutral and has a pH of 7. Values less than 7 are acidic. Values greater than 7 are alkaline. Rain averages slightly acidic, about 5.2. The ocean is slightly alkaline at 8.1. And the human body is right in between at 7.4. Here's the basic problem with the alkaline diet. Its fundamental assumption that you can change your body's pH level by changing what you eat violates everything we know about the chemistry of the body. Your body always stays at 7.4 because the enzymes that trigger virtually every chemical reaction in your body only work in a very narrow range. If your body actually became even slightly acidic or alkaline, you would die very quickly. Your body's main mechanism for regulating its pH level is your respiration. We exhale carbon dioxide, which comes into your lungs right from the blood. If your blood becomes even slightly acidic, you'll exhale more CO2. If it becomes alkaline, you'll exhale less. This is both rapid and effective. The slow metabolization of food can't compete with the respiratory system's fast and powerful response to changes in pH. Your kidneys handle the rest of it, removing acids or bases from your blood as needed. The pH of your urine can be all over the place, depending on what was removed from your blood. Urine is the only bodily fluid whose pH can change based on what you eat. Some marketers of alkaline diets take advantage of this by fooling customers into buying urine pH test kits, hoping to trick you into thinking your urine's pH reflects your body's pH. It doesn't. So what happens when you drink alkaline water or eat an alkaline diet? Nothing. Your stomach full of hydrochloric acid is extremely acidic. As soon as the food moves to your intestines, pancreatic secretions bring it back up to 7.4. All of this means the belief that an acidic body is the cause of cancer and other diseases is pure fiction. If anyone tells you that, don't listen to anything else they say. They need to revisit high school biology. I'm Tamara Robertson, and your feeding tube is out.
And that's the feeding tube. I love their videos. I just don't like their name. And I do have other videos that I show of hers. I don't know if I do it in this class. Her hair doesn't bounce around as much. So I want you to know that she talked about why you don't need to worry about the diet affecting the pH of your blood. We have a buffer system. This picture, this is to show you that the pH system is carbonic acid and bicarbonate. You don't need to know the details of it. I just want you to know that buffers help maintain the blood pH. Nothing that you eat is going to affect the pH of your blood. And like she said, if anybody's trying to tell you that, don't listen to them. It doesn't matter if they're football players or movie stars. They don't know anything about nutrition or chemistry. Categories of minerals, because we have categories for everything, we categorize minerals as major and trace, and that's based on the amount of minerals present in the body. The major minerals are the ones found in greater than 5-gram amounts. The ones found in our bones include calcium, phosphorus, and magnesium. The major minerals found in water, sodium, chloride, and potassium. They're also the electrolytes. And lean body mass, our muscle tissue, the major mineral is sulfur. Trace minerals are in less than or equal to 5-gram amounts. The one that I think we're only going to talk about is iron. Here's a table to help you remember the difference between major and trace. I guess for our purposes, iron fluoride will be the only trace minerals that we'll talk about. Again, it has nothing to do with the importance of the mineral. It has to do with the amount that's found in our body and how much we need to get in our diet. Other minerals that are found in the body but are not recognized as essential include boron, silicon. You can look at these. Just because your supplement has these doesn't mean that they're essential. It means that they're cheap and that they're easy to put in a supplement. Don't pay extra for these. When they become essential, when enough studies are done in humans that shows that there is a specific deficiency associated with that specific nutrient, when it's taken out of the body, that's reversed when it's added back in, then you'll want to get that in your supplement. But of course, this being a nutrition class, I want you to get your nutrients from food. They're more bioavailable. Water, probably the most important nutrient, because you can go for several days without food, several weeks even. You can only go for a couple days without water. Water is essential because you can develop a deficiency more quickly from not having water than any of the other nutrients. It's also needed for everything that goes on in our body. Remember, all the reactions that occur in our body require enzymes, energy, and water. In terms of how much should you get, there's no one size fits all. The needs vary depending on your activity, on the environmental conditions in which you're exercising, in which you live, and we'll talk about that more when we talk about fitness or if you have a specific question. Most body waste is excreted in the urine. I hate the word toxin. Our body does not need to be detoxed because we have if you have a functional liver and kidney, and that's important because when we break down proteins, and this is cocktail chatter for now, we don't use the nitrogen from the amino acid. It is used to make ammonia, which is toxic. However, as long as your kidneys are working, as long as your liver is working, that nitrogen forms urea and gets excreted in the urine. So to summarize, we have non-caloric nutrients, vitamins, minerals, and water. Vitamin and minerals are micronutrients. Vitamins are categorized as fat and water soluble. Minerals are categorized as major and trace. And because I don't want you to think I lack for poetry in my life, water is the fluid of life.